Hi guys, welcome to chapter 11, and this is agriculture, feeding the world. So here we go. Love that picture. You've seen him in our movies and with his chickens, of course. Okay, so there's a few things you need to know about agriculture and nutrition. We're talking about feeding the world, and the fact is there's a few things that you probably have not thought about. One of them being undernutrition. Undernutrition means you're not getting the amount of calories and nutrients that are required for you to be healthy. And as you can see, that has recently gone up. And it's not necessarily that we're not providing enough food. It's that not necessarily the people get the food. There's a problem with distribution of food, not available or not production of food. We actually produce enough food to feed everybody on the planet, but not everybody has the money for it, and it's not necessarily, the food isn't necessarily there for them to have. In the United States, you go into a grocery store and every single aisle is full of food. That's not true in all other countries. So there's some issues. Again, undernutrition means that you're not consuming enough calories to be healthy. Malnutrition means you're not getting enough of the right nutrients and minerals and vitamins and that kind of thing. Your diet lacks those things. You can actually eat more calories than you need to and actually be fat and still be malnourished because you're not getting the right vitamins and minerals. If you're just eating, potato chips and stuff and that's all you eat, you're getting tons of calories, but you're not getting all the nutrients you need. Overnutrition is consuming more calories than you need. And of course that leads to people being overweight, which of course is a global phenomenon at this point for a variety of reasons. Okay, annual meat consumption in the United States has gone up. We actually eat twice as much meat as your great-grandparents did in the 30s and 40s. And globally that's true. We see meat as a wealthy thing, meat as a good thing, and we have upped our protein intake, which is not a very good thing overall. Grain production, we've increased our grain production, but the amount of grain is actually going, or a lot of that grain is actually going to feed those cattle and that stuff for meat production. So you should be familiar with these, but it's not a huge deal. Reasons for undernutrition or malnutrition. Poverty is the biggest one. You just don't have the money to buy healthy food. You go in the grocery store and the crappy food, excuse my language, the less nutritious food, the potato chips and the pretzels and the junk food is actually a lot cheaper than your broccoli and your avocados and your tomatoes and stuff. So to eat healthy and to eat well is expensive. Political and economic factors. This is one of those things that if you have political issues, a lot of times in the United States we've tried to take food into areas and half that food's taken by the government and sold to another government to make money to line their pockets. It doesn't get to where it's supposed to be, which is a very sad thing. And then some of your food is diverted to feed your livestock, your cows, your chickens and stuff, rather than feeding people. And also some of it's diverted to those rich Americans who will pay a lot for an avocado. Are you going to sell the avocado for $1 to an American or 10 cents to the person that lives next door? So unfortunately, to some degree, we also price things out rather than food staying where it is to feed the people in that area. It's being shipped to Europe or the United States and stuff for people who will spend more money on it. Okay, the green revolutions. You need to know what a green revolution is, and it's not a good thing. Usually green revolutions would be considered a good thing. This is not a good thing. This is an advancement that has allowed us to increase our production of food, of agriculture. So the invention of tractors, the invention of fertilizers, or the creation of fertilizers, the use of irrigation systems, the use of pesticides, the use of GMOs, all those things are green revolutions. They allowed us to dramatically increase our production of food. That's a green revolution. They're not necessarily good things, but they're not necessarily bad either. But, a lot of time when you hear green, it's supposed to be good. Not necessarily in this case. Depends on how you look at it. Okay, irrigation. Later, we are going to do a salinization lab next week. Waterlogging and salinization are two negative outcomes to irrigation. Irrigation is sprinklers and drip systems getting water to your plants for agriculture. In agriculture, we use a lot of irrigation primarily because we're growing things where they shouldn't be grown. We're growing crops in areas where there's not naturally enough rain for them, and so we have to provide the water. And this is the number one use of water in the United States is for agriculture. Waterlogging is when you just actually apply too much water. You literally waterlog the plant. The plant gets really, really wet. The water basically depletes the amount of oxygen in your soil, and your roots will start to rot and your plant will die. Salinization salinity is salt. So this is an increase in salt in concentration in your soil. And what happens is all water has salt in it. Fresh water has very little salt, but it has salt. So as you use irrigation and the water evaporates off, it leaves some of that salt behind. And over time, that salt will build up until you get saltier soils, and salty soils can't necessarily hold your plants. And you'll see that when we do the lab. But here's an example. This is waterlogging. Here you can see the water. It rises up and literally soaks out your roots and stuff. By the way, that's a center pivot. Over here in the center is a well. And then this literally goes in a big circle around, and it has sprinklers all on this. Sprinkler systems are by far the least effective form of irrigation and more likely to cause salinization stuff because of huge amounts of evaporation while the water is in the air. Okay. I think we come back to irrigation. Hopefully we do. Fertilizers. We apply fertilizers to the soil because we are removing the nutrients, the nitrogen, the phosphorus, the potassium, all those kind of things. We grow plants. All those nutrients are contained in the plants, and then we ship the plants somewhere else. So we don't allow the nutrients to cycle within the system right there. So we have to provide more of those nutrients for the next crop to grow. You have organic fertilizers. These are your natural organic material, your manure, dead plants, your compost, that kind of thing. Decomposing natural stuff. That's your organic. Organic's better. Organic is not as easy and stuff, but it will hang around longer because it's usually in a solid form. It's in a compost kind of form, a material kind of form. Your inorganic fertilizers are your synthetic. These are the ones we are making in factories. They are usually liquid or some kind of little pellet. They dissolve quickly. They're available very rapidly for the plants to use, but they can also wash away quite rapidly too and cause eutrophication and stuff in our water system. So we'll talk more about eutrophication when we get to water. Water pollution. Okay, so we actually, humans, now fix more nitrogen than nature does for fertilizers. So most of our fertilizers that are being used on our crops are synthetic or inorganic fertilizers. Not a good thing, but it's the way it goes. Okie dokie. Monocropping. Mono means one, so monocropping is just acres and acres and acres and acres and acres of the same product. This, of course, is pictured as wheat. You have acre and acre and acre after acre of wheat. As far as the eye can see, you have wheat. Monocropping, it has some negatives. If you have a disease or a pest come in, it's just acre upon acre of the same stuff, so they will destroy it very rapidly. It decreases your biodiversity in the area, which we know is bad. It's just, and most of our monocropping, honestly, is things like wheat, corn, soy, and most of that is going for, cattle feed and stuff like that. So it's not necessarily for human consumption. A lot of it's GMOs as well. But make sure you're comfortable with monocropping. Pesticides. We have pests. And a pest is anything that is hurting your crops. So it can be a disease, it could be an insect, it could be another plant, it can be just about anything. Anything that any kind of organism, disease or whatever, that we want to control, referred to as a pest. So a pesticide is a broad spectrum, gets rid of whatever. If you're going to, you can get more specialized things, like an insecticide targets insects, or an herbicide targets plants that you don't want to grow there. Roundup is an herbicide. It targets plants that you don't want there. So, and when you get your, Raid, ant killer, or whatever, that's an insecticide. But broad terms, we call them pesticides. I'm yawning, sorry. Oh, pesticides, you have to be familiar. We're going to run through pesticides in class. A broad spectrum pesticide is just that. It's broad spectrum. It'll kill just about anything. So if you get an insect spray that will kill any kind of insect, ant, roach, spider, whatever, then that's a broad spectrum. If you have a selective pesticide, it's something that's literally made just to kill that one critter. If you get cockroach killer, and all it does is kill cockroaches, then you've gotten a selective pesticides. Selective pesticides are better because they'll select for and only kill the one thing you want to kill. Broad spectrum could ultimately end up killing and harming a lot of good insects, beneficial insects like bees and all, which is why we have to be careful when they were spraying for Zika and stuff. You're not just going to kill the mosquitoes, you're going to kill some other organisms as well. Okay, then with pesticides, they can be broad spectrum or select. Now they can be persistent or non-persistent. Persistent means it remains in the environment for a very long time. Well, we're going to talk about DDT, and that's a very persistent pesticide. Non-persistent means it breaks down very rapidly. If you've used Roundup lately, Roundup, you can buy ones that say within 3 days you can plant your normal plants, which means it's going to break down and no longer be harmful in 3 days. So that's non-persistent. That breaks down very rapidly. Some of them can be quite persistent and literally last years, if not tens of years. Bioaccumulation, again, DDT is a big example of this. You get bioaccumulation when you have pesticides that are persistent. DDT lasts 50 plus years in the environment, and it can build up in the tissues of organisms, and it accumulates as you go up the food chain. So at the top of the food chain, we have things like hawks and eagles and bird-eating or fish-eating birds, your pelicans and stuff. They got really high levels of DDT. DDT actually caused them to form weaker eggshells, and when they went to sit on their eggs, they would actually crack them. And we lost generation after generation of our fish-eating birds, or osprey and pelicans and bald eagles and stuff, due to DDT building up in the environment. Bad thing. Other things can, of course, bioaccumulate too. Lead and mercury and that kind of things. A lot of those toxins can, but DDT is the classic pesticide that has bioaccumulated. Resistance. You know what? Let's see. I only got 2 minutes. Can I do this in 2 minutes? Yeah, I can do this in 2 minutes. Okay. Organisms can build up a resistance. If they're not killed by the pesticide, they will build up a resistance to it, and they will genetically pass that resistance on to their offspring. Till finally, you end up with a pesticide or an organism, population of organisms, that no longer dies when treated with that pesticide. So now you have to get another nasty pesticide, a nastier one. So that does the same thing. And this ends up causing what we call a pesticide treadmill. Initially, pesticides work, but over time, because of maluse and because of just resistance, your population will increase again until you have to have a nastier thing. This is something we also see with antibiotics. This is why you have to, I yell at you about taking your antibiotics correctly if you have them, because our bacteria are also building up this resistance to our antibiotics, which is why you have, superbugs and stuff like that anymore. Okay, let's cut this off. I will see you guys in the next video. Enjoy.